6.6 Trigonometric function applications. So here are the tips for you to solve a trigonometric equation. First, simplify the equation. Second, find the reference angle. Third is find the angles in the quadrants that corresponds to the signs of the trigonometric ratio and range. Last is write the solutions obtained. So let's recall. Location of angles can be specified in terms of quadrants: 0, 90 degree, 180 degree, 270, 360. So here are the location of reference angle on each quadrant. So quadrant 1, theta is equal to reference angle. Quadrant 2, theta is equal to 180 minus reference angle. Quadrant 3, theta equal 180 plus reference angle. Quadrant 4, theta equal to 360 degree minus reference angle. So just remember the formula that is highlighted here. The sign of the trigonometric ratio in a quadrant can be memorized by using ASTC, where A, all sine, cos, tangent are positive in quadrant 1. S, only sine is positive in quadrant 2. T, only tangent is positive in quadrant 3. C, only cosine is positive in quadrant 4. To solve a trigonometric equation, knowledge of a trigonometric identities, the reference angle and the sign of the trigonometric ratio in a quadrant are important. Let's look at the example now. Solve the following equations for range from 0 to 360. A sin theta is equal to negative 0.5446. So first we find the reference angle. Shift sin 0.5446 without taking into consideration the negative sign, and you will get the reference angle is equal to 33 degree. From the equations, we know that sin theta is negative. So sin negative is in the third quadrant and the fourth quadrant. So here are 33 degree. Formula in the third quadrant is 180 plus 33, and fourth quadrant is 360 minus 33. So theta is 213 degree and 327 degree. B cos 2 theta is equal to 0.3420. So the reference angle is equal to shift cos 0.3420, which is equal to 70 degree. The range given in the equations is from 0 theta to 360 degree. So the angle given in the equations is 2 theta. So everything must double up. So from 0 to 720 degree. Cos positive means that it falls in the quadrant 1 and 4. Bear in mind the range is from 0 to 720. So 2 theta is equal to 70 degree. 360 minus 70. 360 plus 70. And it rotates 2 times, so 720 minus 70. 2 theta is equal to 70 degree, 290 degree, 430 degree, and the last one you can also find it by 360 plus 290, which is equal to 650 degree. So theta is equal to 35 degree, 145 degree, 215 degree, and 325 degree. Next question, solve the equation 3 sin a plus pi over 3 equals 0.99 for range from 0 a to pi. 3 sin a plus pi over 3 equals 0.99. Sin a plus pi over 3 equals 0.99 over 3, which is equal to 0.33. Find the reference angle. Shift sin 0.33 equal to 0.3363 in radian. change the calculator in radian mode first. So for calculator 570ES, you can press shift mode 4, and calculator 570MS, you can press mode 4 times until you can see radian and then press button 2. Let's continue. Check the range from 0 A to pi, but from the question the angle is A plus pi over 3, so we have to modify the range. So A plus pi over 3, so from pi over 3 to 4 pi over 3. Easy to see if we change it to 1.047 radian and 4.189 radian. Sign is positive, so it falls in the quadrant 1 and 2. A plus pi over 3 is equal to 0.3363. Pi minus 0.3363 equals 0.3363 2.8057 radian. So A is equal to 0.3363 minus pi over 3, 2.8057 minus pi over 3, and you will get A is equal to negative 0.7109, 1.758, which one is in the range between 1.047 and 4.189 radian. So negative 0.7109 is outside the range, hence A is equal to 1.758 radian. Next question, find the values of x that range from 0 to 360 degree that satisfy the following equations. A sin 2x plus cos x is equal to 0. So we use the double angle formula. Sin 2x we change to 2 sin x cos x plus cos x equals 0. So here we can factorize cos x bracket 2 sin x plus 1 equal to 0. So cos x is equal to 0 and 2 sin x plus 1 is equal to 0. So for cos x is equal to 0, easy for us to see it by using graph. So the angle is 90 degree and 270 degree. 2 sin x plus 1 is equal to 0. Sin x is equal to negative 1 over 2. So the reference angle is 30 degree. Sin is negative, so it falls in the quadrant 3 and 4. Remember the formula involved. So x is equal to 180 plus 30 degree, 360 minus 30 degree. So x is equal to 210, 330 degree. So here are the solutions obtained. Hence x is equal to 90 degree, 210 degree, 270 degree, 330 degree. B. 2 cos 2x minus 13 sin x plus 10 equals 0. Sin and cos mix together, so make it all in terms of sin. 2 cos 2x, we use the double angle formula and change it to 1 minus 2 sin square x minus 13 sin x plus 10 equals 0. 2 minus 4 sin square x minus 13 sin x plus 10 equals 0. Negative 4 sin square x minus 13 sin x plus 12 is equal to 0. 4 sin square x plus 13 sin x minus 12 is equal to 0. So this one looks so complicated, so we try to make it look simpler like this. 4x squared plus 13x minus 12 equals 0. So you factorize it like usual. 4x minus 3x plus 4 is equal to 0. X is equal to 3 over 4. X is equal to negative 4. Actually, the x is sine x. Refer to the right hand side. Bracket for sine x minus 3, sine x plus 4 is equal to 0. So sine x is equal to 3 over 4 and sine x is equal to negative 4. For sine x equal 3 over 4, find the reference angle. Like usual, reference angle is equal to shift sine 3 over 4, which is equal to 48.59. Sine x is positive, so x is in the quadrant 1 and 2. So x is equal to 48.59. 180 minus 48.59. So x is equal to 48.59. 131.41 degree. Sine x is equal to negative 4. We ignore because the range is from 0 sine x to 1. Hence, x is equal to 48.59, 131.41 degree.